On November 9th, the world received two images it wasn't prepared for. The Virtual Telescope Project and the James Webb Space Telescope dropped the latest shots of the interstellar traveler known as 3I/Atlas. And the results have left the scientific community speechless. In these frames, the object appeared as a tight, brilliant dot of light. No trace of a tail, no outgassing, no cloud of dust. Nothing you would expect from a body shedding billions of tons of material near the sun. But here's the most unsettling part. It looks exactly the same as it did back in July, when Hubble last photographed it. For an object that should have lost over 5 billion tons of mass to solar heating, that static appearance is a cosmic insult to every known law of cometary physics. To some, it is a simple anomaly. To others, it is something much larger. Harvard astrophysicist Avi Loeb calls it a wake-up call from the cosmos. Because if these images are what they seem, a body speeding up through the solar system without ejecting anything, then 3I/Atlas might not be a comet at all. It might be built. It started in late October when astronomers caught something strange. As 3I/Atlas hit perihelion, its closest approach to the sun, the object didn't slow down. It accelerated. This is impossible. According to NASA's Jet Propulsion Laboratory, Atlas deviated from its predicted path by 4 arcseconds. A tiny angle, but at a distance of 203 million kilometers, that represents a shift of tens of thousands of kilometers. Something massive was pushing it off course. The calculations stunned the mission analysts. The object was accelerating outward at 0.22 mm, such as superscript 2, while drifting sideways at nearly the same rate. In a single month, that is a displacement of over 80 kilometers, far too big to be a random fluctuation. The question rippled through every observatory from Chile to Hawaii. What invisible hand was steering this thing? The standard answer: outgassing didn't work. To get that kind of thrust, Atlas would have needed to vent a sixth of its total mass, equivalent to 5 billion tons of vaporized gas, creating a blinding halo visible even to backyard telescopes. But the sky stayed empty. No cloud, no tail, no vapor. Nothing. To show just how absurd this is, the Virtual Telescope Project posted a side-by-side comparison between 3I/Atlas and Comet Lemon, a completely normal comet shot under identical conditions just days earlier. Lemon behaved as expected, a ghostly, radiant tail streaming away from the sun, sculpted by solar radiation. But Atlas? It remained a sharp, unblemished. It was like comparing a statue to a living organism, one radiating energy and motion, the other frozen and silent. For Atlas to accelerate without leaving debris is like watching a rocket fly without exhaust. The physics don't just fail, they collapse. When Loeb ran the numbers, he found that if the acceleration were truly cometary, the outflowing gases would have created a glow brighter than the full moon. And yet, the November 5th images show nothing of the sort. The magnitude, color, and symmetry all remain eerily constant. Gianluca Massi, the Virtual Telescope's director, called it the most baffling observation he has ever made, because even instruments built to find faint traces of dust returned the same reading: 0. When the data reached Harvard, Loeb and his team started reconstructing the physics behind the acceleration. Using an estimated mass of 33 billion tons, nearly 1 million times heavier than Oumuamua, they concluded that no natural process could explain the force acting on it. Solar radiation pressure was too weak. Outgassing was invisible. Gravitational interactions were impossible at that distance. That left one option: an unknown mechanism. "We have to accept what the data shows us," Loeb said. "If the physics fails, the theory must adapt." But few were ready to adapt to the implications. The truth was too heavy, because the numbers didn't just describe motion. They described intention. The acceleration wasn't random. It was smooth, consistent, and perfectly aligned with the sun, as if someone or something had calibrated it. The last time we saw behavior remotely like this was with Oumuamua. But this time, the effect was stronger, faster, and far more deliberate. As data poured in from telescopes globally, a pattern formed. 3I/Atlas wasn't just breaking one rule. It was breaking all of them. Its orbit hugged the ecliptic plane within 5 degrees of the path followed by Earth and the other planets. A coincidence so improbable Loeb called it hitting a cosmic bullseye in the dark. Then came the jet anomaly, a burst of material shooting directly toward the sun, the opposite of what any comet does. Normally, solar radiation pushes dust away, forming tails that point outward. But Atlas defied even that, as if repelling sunlight itself. Its speed was another impossibility, faster than lighter bodies like Oumuamua and Borisov, even though its mass should make it sluggish. And its brightness curve defied logic. As it neared the sun, it brightened to magnitude -7, double the intensity of any known comet. Then came the color, blue. Not icy white, not fiery red, but an electric spectral blue, hotter than the sun's own photosphere. Its surface temperature seemed to exceed 5,800 Kelvin, a feat no natural object can achieve without vaporizing. By now, astronomers weren't just confused, they were alarmed. Because if 3I/Atlas isn't following the rules of celestial mechanics, then it is following something else. Perhaps a command. Spectroscopic scans from James Webb and ground-based observatories revealed something even stranger: the composition. Unlike natural comets, which are chaotic mixtures of ice, rock, and minerals, Atlas displayed a precise nickel-to-iron ratio, the same ratio found in high-temperature alloys used in spacecraft and jet engines. In nature, metals blend chaotically, but Atlas's metals were balanced, refined, and organized. It also held only 4% water, making it drier than Earth's driest deserts. Not the dirty snowball we expect, but a structure that looks forged, not frozen. Some scientists now suspect the outer shell might not be natural at all. It could be a ceramic or composite layer, heat-resistant and polished, explaining why it reflects light so cleanly without showing cracks. That reflection produces an unprecedented polarization signature. Light waves aligned with mathematical precision, something never seen in a natural body. As Loeb said, if you were to design a probe to survive a billion-year journey across the galaxy, it would look exactly like this. And then came the revelation that stunned even the skeptics. When researchers plotted the trajectory of 3I/Atlas, they noticed its path intersects the orbits of Mars, Venus, and Jupiter, but not Earth. Its timing was perfect. During perihelion, when it should have been easiest to observe and closest to Earth, it positioned itself behind the sun, hidden from our instruments. This alignment is so statistically improbable that some astrophysicists now believe it cannot be coincidence. This isn't random, one JPL analyst said. It's deliberate navigation. The idea sounds insane until you look at the math. The orbit is so precise that if you plot it backward, it points directly toward the same region of the sky where the WOW signal originated in 1977. A narrowband radio burst SETI has chased for decades. Two phenomena, decades apart, from the same cosmic coordinates. Coincidence? Maybe. But as the data mounted, maybe began to sound a lot like denial. Every new image released by the Virtual Telescope Project only deepened the mystery. 3I/Atlas's color, that deep ultraviolet blue no comet should emit, defied every thermal model. Blue light means energy. Blue light means temperature. And yet, the object showed no decay, no fragmentation, no infrared heat signature. It was glowing with light that wasn't heat at all, light that seemed self-generated, like radiation from ionized gases or plasma under control. Some plasma physicists have proposed the object could be using electromagnetic propulsion, generating thrust by manipulating the solar wind, technology humans have only tested in labs. Others believe it could be simpler, the remnant of a machine so ancient and autonomous that it operates on instinct long after its makers are gone. If true, we may not just be observing alien technology. We may be witnessing alien persistence, a mechanism running its mission after eons of silence. And so the countdown begins. On December 19th, 2025, 3I/Atlas will make its closest approach to Earth, passing at 167 million miles. Close enough for every major telescope from Webb to Hubble to capture it in unprecedented detail. If it is a comet, we will finally see the massive gas cloud physics demands. But if no cloud appears, if Atlas remains the same silent, blue, perfectly compact body it has always been, then the entire cometary explanation collapses. What remains is far more disturbing. Could it be a probe? An autonomous observer scanning our system as part of an ancient experiment? Or something even stranger, a device designed to activate when civilizations like ours reach the nuclear threshold, as some speculative physicists fear? For now, no one knows. But every spectral line, every image, every silent motion in the dark suggests one thing. This object is watching, and it may not be done yet. As the newest images from the Virtual Telescope project make their rounds through every lab and forum on Earth, one feeling hangs in the air heavier than wonder: unease. The cosmos has just handed us another impossible riddle. And this time, it is staring right back. 3I/Atlas continues its journey through the solar system, cold, blue, and silent, defying every equation we have ever trusted. It doesn't look like an asteroid. It doesn't behave like a comet. It doesn't fit into any of the tidy boxes human science has built to make sense of the sky. It accelerates when it should decelerate. It burns blue when it should glow white. It hides when it should shine. It follows a path that looks less like coincidence and more like choreography. And yet, when the data arrives, it arrives with perfect clarity. No noise, no error. As if the universe itself were forcing us to see something we have spent centuries trying to ignore. The more we learn, the less we understand. Every new image deepens the paradox. The same compact, luminous point of light. Perfectly stable, perfectly calm, perfectly alien in its indifference. It is as if the sun itself can't touch it. As if gravity, radiation, and heat all slide off its surface like light from a mirror. If it is natural, then it is rewriting our definition of what natural means. If it is artificial, then we have just witnessed the most profound discovery in history. Evidence that we are not the first to walk beneath these stars. Either way, the world we thought we understood has already changed. Because the question isn't whether this object is a comet. That question died the moment it accelerated without a tail. The real question, the one no one dares say aloud, is this: what kind of intelligence designs something that can travel for billions of years across interstellar space, powered by nothing we can detect, guided by precision we can't explain, and still function flawlessly after eons? What kind of civilization does that? Are they still out there now? Or are we watching the drifting relic of their memory? A ghost ship crossing the cosmic ocean, repeating its mission long after its makers turned to dust. Dr. Avi Loeb warned us years ago that when science refuses to face anomalies, it turns into dogma. We cannot claim to be seekers of truth, he said, if we only accept the truths that make us comfortable. 3I/Atlas is that discomfort, a reminder that the universe is not obligated to fit inside our theories. It never has been. The sun does not ask our permission to burn. The stars do not require our approval to shine. And when something enters our skies that we can't explain, we are meant to question, not to dismiss. So, here we are again, staring at another visitor from the dark, and the silence around it feels almost intentional. Perhaps this is how first contact really happens. Not through flashing lights or radio signals, but through subtle defiance. Through quiet impossibilities that force us to look again, to think differently, to evolve. Maybe that is the lesson of 3I/Atlas. That discovery isn't about conquering the unknown, but learning how to stand in front of it without fear. And now, as December 19th approaches, the day it passes nearest to our planet, every telescope on Earth will turn toward it. Maybe we'll finally see what it truly is. Maybe we'll see nothing at all. But whatever happens, we will remember this moment. The first time in history that a piece of the cosmos looked back at us and refused to explain itself. Because sometimes the universe doesn't whisper its secrets. Sometimes it shows them to you in plain sight and dares you to believe. If this story made you question what is really out there, don't let it disappear into the noise. Subscribe to this channel, because we will keep following 3I/Atlas until its light fades beyond our reach. Turn on notifications. The moment new data drops, you will know first. And tell us in the comments, what do you think 3I/Atlas really is? A rock? A probe? Or the first message from a civilization that learned how to speak in silence? I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts,